All right, it's nice to see everyone again. Welcome back from spring break and from, last week where you guys were resting a little bit. So I hope those worksheets help to keep everything fresh in your head. And of course, all the notes here are posted on my website. If you go to the PB Works one and click on class notes, or you can get it directly from PB's site. So let's get into learning some new things here. Today I have 4 examples for us, and today is the 27th. This is section 9.5, and it's called solving rational equations. Now, remember, rational just means fraction. A rational number is a number that could be written as a fraction. So when we're solving rational equations, that means that we're going to have some more fractions, but you guys know fractions is my middle name. And we might have equations that look like this. X over 2 plus x over 5 is equal to 1. Now, we talked about how to handle fractions before. We could get a common denominator and then cross multiply, or one thing we could do is get rid of fractions altogether. So I'll show you both techniques, and then you guys decide which way you would prefer. Okay. One way is to get a common denominator and then cross multiply. The other way is to get a least common denominator and then get rid of fractions. And we're going to get rid of fractions by multiplying. So those are the 2 techniques. I'll show this first one both ways, but then going forward I'm just going to show this technique. I think that's the shortest and most accurate way to do it, but you're welcome to do both as long as we get the same answer. So looking at the least common denominator, between 2 and 5, those are our denominators, would be 10. So I want to try to make all of the fractions have the same denominator. So I'm going to multiply this by 5 over 5. If you remember from middle school, that's how we get a common denominator. And we get 5x over 10 plus 2x over 10 is equal to 1. Combine the top, 5x plus 2x over 10 is equal to 1. So that's 7x over 10 is equal to 1. We can make this into a proportion and cross multiply to solve. 10 times 1 is 10, 7x times 1 is 7x, so x would equal 10 over 7. The other way to do this would be to get rid of fractions from the start. So we did this a little bit earlier in the chapter, let me see. Well, we've done this before. You guys know how to get rid of fractions from earlier in the year, actually. So we have x over 2 plus x over 5 is equal to 1. And the LCD between 2 and 5, 2 and 5 both go into 10. 10 is the smallest number that both of them go into. Or, another way to think about it, our LCD needs a factor of 2, and our LCD needs a factor of 5. However you want to think about it, 2 times 5 is 10. So the second technique, we're going to multiply everything by 2 times 5, or 10. Common mistake is people forget to multiply the 1 by 2 times 5, but remember, everything is times the LCD. These would cancel, and you'd get 5x. 5s would cancel, you're multiplying and dividing by the same thing, you get 2x. So 7x would equal 10, and you guys can see that you get the same answer. It's just a little shorter doing it the second way. That's the way I'm going to be doing all the other problems going forward. All right. One other thing you want to check is you want to make sure that you check for extraneous solutions. And what that means is it's possible to do all the algebra right, but when you get an answer, it might not work If you have radicals, we saw extraneous solutions. If you have absolute value, we saw extraneous solutions. And now we're seeing it again with rational equations. So we should always, whenever we have any of these three, just plug the answer in and see if it works. So 10 over 7, if we were to plug it in, and again, you could use a calculator for this, you would get 1 is equal to 1, and everything would work, so it's all good. But you should check whenever you have one of those three types of equations. Alright, so now let's do some more advanced ones. Second example looks like this. 24 over x minus 3 is equal to 36 over x plus 3. Now, in previous sections, we talked about how to get a least common denominator. We would need a factor of x minus 3, and we would need a factor of x plus 3. And this is actually already set up. I mean, we could handle this a couple different ways. One thing we could do is we could just cross multiply. It's already set up as a proportion. Proportion means one fraction equal to one fraction. You learned how to solve this in middle school. The way that I'm going to handle this is like all the other problems in this section. Anytime I see fractions, I'm going to just get rid of them first. So I'm going to multiply everything by that least common denominator. X minus 3 times x plus 3 times 24 over x minus 3 and x minus 3 times x plus 3 times 36 over x plus 3. The x minus 3's cancel, the x plus 3's cancel. Anytime you multiply and divide by the same thing, they do cancel. So 24 times x plus 3 would equal 36 times x minus 3. We could distribute, and this would give us 24x plus 72 is equal to 36x minus 108. We try to get all the x's on the same side and all the numbers on the same side. They're called constants. This would turn into negative 12x is equal to negative 180. And if you divide by negative 12, you get x would equal 15. Not a big deal. You guys could all handle this. A couple more problems here. What about a problem like this? 7 over r plus 2 minus 6 over r minus 5 is equal to 0. The way I'm going to do this is just like the other problems. The least common denominator would be a factor of r plus 2 and a factor of r minus 5. What I'm going to do is I'm going to multiply everything by that least common denominator. Now, it is a little bit of writing, but in my experience, this is the best way to do these kind of problems. Alright, so remember, anytime you multiply and divide by the same thing, they cancel. So this would be 7 times r minus 5 minus the r minus 5's cancel. 6 times r plus 2 is equal to, well, anything times 0, whatever this is times 0, would be 0. So I'm just going to make that 0. 7r minus 35 minus 6r minus 12 is equal to 0. So r minus 47 is equal to 0. R would equal 47. If you were to plug this back in, it would work. You would get 0 is equal to 0. And just think about what could happen to give us an extraneous solution. One thing that could happen is we might get like 5 is equal to 0. And in that case, you would tell us that that's an extraneous solution. Another thing that could happen is what if r is equal to negative 2? Or what if r is equal to 5? that would make our denominator 0, and that can't be. So we could get two types of extraneous solutions here. One where both sides are unequal, and one where the denominators are equal to 0. So that's why we have to check. All right, and none of that happens here, so r is equal to 47 is the right answer. So I'm just going to erase this so we don't get confused. And maybe I'll go back in the notes, and for extraneous solutions with rational equations, just write that over here, that you could get like 5 is equal to 0, which is obviously wrong, or you could get 0 in the denominator. And you know that your denominator can't equal 0. Those are the two types of extraneous solutions you might get. Take a look at one more, and then I'll give you your homework. What if we had x over x plus 2 minus x plus 2 over x minus 2 is equal to x plus 3 over x minus 2? Now, there's a few different ways we could handle this. These have the same denominator, so you could bring it over. But the way I'm going to handle this, just like all the other problems in this section, is I'm going to look for the least common denominator. We need a factor of x minus 2, because that has an x minus 2 and this has an x minus 2. But we also need a factor of x plus 2. So if all of our denominators had those in the denominators, we can combine the fractions. But I'm going to multiply this times everything to just get rid of fractions. And let's see what happens. So the x plus 2's here cancel. We get x times x minus 2. Minus, these cancel. So x plus 2 times x plus 2 is equal to, these cancel, x plus 2 times x plus 3. Now we're going to have to distribute. We'll deal with this minus in a minute. Let's go ahead and distribute this here. We'll distribute this. And now we have to distribute the negative, combine our like terms, and see what we're dealing with. All right, so these x squareds cancel. This would be minus 6x minus 4. Remember, whenever we get to a certain point in the equation, we want to make sure that it's equal to 0. And then if we factor, we would get x is equal to negative 10, and x would equal negative 1. So two answers. And if we look at the original equation, a number that would not work would be negative 2. That would make this equal 0. But that wasn't one of the answers, so we don't have to worry. X also can't be equal to 2, but it's not. We don't have to worry about that. And if you were to plug in those numbers, I did go out and I checked these before the problem, they would work. All right, so both of those answers would be fine. For homework, what I would like you to do is on page 581, I would like you to please do numbers 6 to 9 and 13 to 19. And on practice 9.5, I would like you to please do numbers 1 to 6. All right, please have these done for tomorrow. Thanks for following along. Have a nice day.